TRES-2b, or not to be, is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES-2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri e is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side. And between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. That's a getaway spot. HD 189377b, well, I'm not going to say that again, is the only exoplanet in the orbit of its star, and at first glance it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Better duck. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler-70, hey, I can say that one, is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. So pal, what's eating you? My mother. WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. Hey, you asked. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. I thought I thaw that thumbworth. Still, if it has a rocky core, it might generate some heat, so there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1,800 degrees, perpetually blown over with winds reaching 600 miles per hour. And that's winter. Well, actually, I don't know that. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. That'll test your mettle. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Vacation? Nah, let's keep looking. Karat XO 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Karat 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Karat 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core. So check this out. Astronomers have discovered an exoplanet they're calling Super Saturn. It's got rings over an AU wide. An AU is the astronomical unit, the distance between the Sun to the Earth. That's an incredibly huge ring system, hence its name. Super Saturn is being called Mamajek's object after the astronomer who led the team to whom we owe the discovery. Professor Eric Mamajek of Rochester University in New York found Super Saturn while scouring through data downloaded from wide-angle transit observations. WASP is the acronym for Wide Angle Search for Exoplanets. It's an ingenious project developed in the year 2000 by astronomers at Queen's University in Belfast, Northern Ireland, and St Andrews University in Scotland. Using 4 telescopes, the CCD video cameras on the scopes record the slight dimming of starlight caused by objects passing in front of stars. This is called the transit method of exoplanet detection. So, for example, the planet Venus transits across our view of the Sun every couple hundred years. A black dot, the silhouette of Venus, is visible, crossing in front of the Sun as Venus passes between our line of sight and the Sun. This tiny eclipse causes the amount of sunlight coming to Earth to be reduced by a minuscule amount, also known as teeny tiny. The same is true for all the stars in the Milky Way that have planets going around them. Exoplanetary transits in front of stars must be in direct line of sight with Earth for the starlight to be dim. Such transits do not occur very often. That's why thousands of stars must be looked at simultaneously for as long of a duration as possible, between 4 and 8 hours a night. WASP was created to stare continuously at as wide of a range of stars as possible. Maybe one of them would show an exoplanet transit. That translates into a lot of data being produced, about 40 gigabytes per viewing session. Computer scientists at Leicester University in England developed a computer program to store the data and generate photometric graphs of the light intensity of each star. Open University, also in England, joined the WASP project, took this data, and made it available for research by astronomers worldwide. The graphs of the intensity of starlight show that changes in its brightness are called light curves. These graphs have two axes. One is in the timeline axis, the other one is the intensity of light. As the object, considered an exoplanet, though it could also be a brown dwarf star, crosses in front of the star, the timeline axis keeps track of how swiftly it is moving. It tells us how close the object is to the star, while the brightness axis keeps track of how much the starlight dims. This way, we can find out how large the object is. Now, obviously, big objects will dim the light more and be easier to detect. At present, Earth-based equipment is not sensitive enough to measure the dimming caused by planets as small as Earth. Neptune's size and larger ones are the limit for WASP. However, the James Webb Space Telescope, which is now in operation, has a much greater sensitivity and will be able to resolve the transits of Earth-sized exoplanets. Now, I know you want me to get to Super Saturn, but there's something else you should be familiar with before we get there. If the exoplanet has an atmosphere, or, in the case of Super Saturn, a ring system, the starlight from the star the planet is transiting will shine through the atmosphere or ring system, and that can be detected too. The light curve will show less dimming in the photometric data, because not all the starlight is being blocked. Some light is still getting through the atmosphere or rings. This is important because it gives astronomers a reading of the atmosphere. The James Webb Space Telescope is fitted with spectroscopes that can determine the gas content of the transiting exoplanet atmospheres: oxygen, methane, carbon, etc. The WASP project has been really catching on. There's a Super WASP project now consisting of WASP North and a WASP South. One looks at the sky above the northern hemisphere, the other looks at the sky above the southern hemisphere. There's also a Next Generation Transit Survey, NGTS, based on the WASP project. It's automated, so astronomers don't have to stay up all night sipping coffee, but they can if they want to. Located at the European Southern Observatory in the Atacama Desert in Chile, the NGTS scans millions of stars and has discovered over 100 exoplanets, down to a size as small as 3 times the size of Earth. NGTS has started a Planet Hunters Club on social media. Citizen scientists can search the online database of light curves and perhaps discover your very own exoplanet. What had been a strictly British effort started by 1 or 2 astronomers is now a worldwide phenomenon. With the ability to read the spectroscopic signatures of atmospheric gases during exoplanet transits, a new idea emerged: technosignatures. That is, specifically identifying gases in exoplanet atmospheres that are produced by civilizations. The James Webb Space Telescope can do this. Gases from pollution, such as chlorofluorocarbons (CFCs), can be seen spectroscopically if present. Tritium from fusion reactions, if they have them, can also be detected, along with heat patterns from cities on the planet's surfaces. Technosignatures is a recent concept that originated after the WASP project started. Who knows what it will turn up? Now, let's get back to Super Saturn. The star that Super Saturn orbits is J1407, a small, dim, sun-like pre-main sequence star of the 13th magnitude. Huh? Well, the human eye can only see stars to about the 6th magnitude, and each magnitude is 2.5 times dimmer than the previous one. So, it's not an exceptional star, just another telescopic star out there in the Scorpius Centauri region of the night sky. J1407 is a young star that hasn't yet settled into its stable, long-duration phase. This is important because Super Saturn, officially J1407b, is showing signs of having a ring system in an early stage of development. Super Saturn's light curve was tucked away in the mountain of data from the Super-WASP project. Professor Eric Mamajek and his associate Matthew Kenworthy of Leicester University studied the data thoroughly and produced a detailed report on it. Knowledge depends on good data. The horizontal axis of J1407b's light curve, the time axis, is what's causing all the hubbub. It took Super Saturn weeks to transit across in front of its parent star, 56 days to be exact. Planetary ring systems that we are familiar with in our solar system orbit right around the equators of the gas giant planets and are very thin, from only a few meters thick down to a few centimeters. In a telescope, Saturn's rings will seem to disappear when the planet is at zero inclination toward Earth. Saturn must be inclined at an angle in relation to Earth to see Saturn's beautiful ring system. It's something everyone should make a point of seeing: Saturn in a telescope. If Super Saturn's rings blocked most of the light from J1407 for 56 days, it means that the planet had to be orbiting at a steep inclination to its star. If it were at zero inclination, we wouldn't see the rings blocking any light. Therefore, the orbital time could be determined, 10 years minimum to 200 years if the orbit is highly elliptical. The superplanet itself is calculated to be 24 times the mass of Jupiter, which means that if it is gaseous, it could be a brown dwarf star. Super Saturn appears to have a Mars-sized object orbiting around it, because there is a huge gap in the rings that was most probably cleared out by a large object. The Cassini division in the rings of Saturn is where the moon Mimas has cleared out a path through Saturn's rings. The light curve of Super Saturn has only been observed once. All the exoplanet detection systems are keeping an eye out for it to come back around J1407. No one knows when that will occur. Some astronomers have suggested that J1407b is a brown dwarf star system in itself, merely passing in front of, but not connected to, star J1407. An orbital reappearance of Super Saturn would disprove that conjecture. The center region of Super Saturn blocked out all the light from its primary star. This is what indicates that the ring system is new and in an early developmental phase. Over time, the very dense ring mass close to the planet is expected to thin as all this matter gets absorbed into the planet or ejected into space. This is what has happened with our solar system's gas giant planets. The Mamajek object is a shocker. Never before or since has a light curve been detected like Super Saturn's. Super Saturn has added a new chapter to our understanding of the formation of ring systems. So, here's to you, Super Saturn. Hope to see you again soon.
Our universe is full of both amazing and terrifying things. You already know about quasars, black holes, dark matter, and so on. But how about the horrors of space that you haven't even heard of? Would you like to visit the most bizarre worlds in the universe? And it's not me who made this list, but NASA themselves. Welcome to the Galaxy of Horrors, NASA's awesome Halloween collection. Please join me on a journey to some planets and tell me which ones you would consider the most horrible. Buckle up! Our first destination is a gas giant called TRES-2b. It's located 750 light-years away from us. If we used a regular spaceship, it would take us about 10 million years to get there. TRES-2b orbits a yellow dwarf, a star similar to our Sun. It also weighs about 1.5 times more than Jupiter. So, what's so special about it? Well, if you're afraid of the dark, you definitely don't want to visit this place. It's the planet of eternal night, the darkest one of all the planets known to us. But it's not that far from its star, so why is that? The thing is, the surface of TRES-2b reflects light even worse than coal does. Because of this, it seems that there's no light at all. If you were flying across the surface of this planet, it would be like walking with a blindfold on your eyes. Oh wait, actually there is some light. An eerie deep red glow surrounds the surface of the planet. This glow is created by the burning atmosphere, which makes TRES-2b a scorching planet. The air there is even hotter than lava. Oh, but if you think that was bad, let me show you the next place of our horror journey. NASA wasn't beating about the bush while nicknaming this one. Now, we're not just talking about one planet, but 3 at once. They're also located quite far away, 2,300 light years from the Sun. We would have reached them by ship in about 35 million years. All the planets are in the constellation Virgo, and each is extremely light, much lighter than the Earth. These 3 exoplanets are called Poltergeist, Dragger, and Phobator. Cool names, huh? It's because each of these planets is about to become a ghost soon. The thing is, they don't revolve around a star, but around a pulsar. Pulsars are rotating neutron stars with an extremely powerful magnetic field. In simple words, these are the stars that exploded one day. After the explosion, they usually emit such a powerful pulse that it causes the star to rotate at an unimaginable speed, several thousand rotations per second. At the same time, they constantly emit electromagnetic pulses that affect everything around them. So, you've probably already guessed what's happening with our zombie planets. They're slowly, gradually being destroyed under the gigantic influence of radiation. One day, they'll disappear without a trace. Ghost-like planets orbiting an undead star? Yeah, Zombie World is a fitting name. It's also not surprising that scientists nicknamed this pulsar Lich, despite the long official name. Well, at least these guys stick together on their final dance. This planet has a long name, so bear with me. HD 189733b. This gas giant is 65 light years away from us. It would have taken around 1 million years to get there on a spaceship. This planet is slightly more massive than Jupiter and orbits its star, an orange dwarf, all alone. At first glance, it may seem friendly. A pleasant blue color and curls on the surface. Kind of resembles a summer sky or foam on sea waves, right? Oh, looks are very deceptive, my friend. This planet has a pleasant cobalt blue color due to the hazy blowtorched atmosphere. This atmosphere contains silicates that condense when heated. In other words, the clouds on this planet have rain made of glass. Yes, it rains hot glass shards here. Oh, and if that's not enough, there's a raging wind on the surface, which is moving at a speed of 5,400 miles per hour. Just to compare, the fastest wind on Earth had a speed of 254 miles per hour, about 20 times weaker. And because of this, hundreds of thousands of glass shards rush horizontally across the planet's surface at breakneck speed. I really don't envy anyone who would want to try to land there. By the way, this isn't the only example of strange rains in our universe. For example, it rains molten iron on the planet Dimidium. Or let's take so-called carbon planets. Their existence hasn't yet been proven, but if they do exist, there would be tons of black poisonous clouds, and it would rain pure gasoline and hot liquid asphalt. Oh, and also, raindrops would explode upon touching the surface. Nothing special. The next planet, though, is actually really strange. It didn't just revolve around its star, it lived inside the star. This cosmic miracle is called Koi 55b, or Kepler 70b. This planet is very far away from us, 4,000 light years. It would take about 70 million years on a spaceship. It's twice as light as Earth and fully rotates around its star in just a couple of hours. A long time ago, it was an ordinary Earth-like planet about the size of Jupiter. It was peacefully and calmly orbiting its red dwarf star, Koi 55. But everything changed about 700 million years ago. Perhaps you've heard that in a couple billion years, our sun will begin to expand into a huge star, absorbing everything in its path. Well, this is the fate of red dwarfs. Sooner or later, they increase, turning into incredibly hot blue giants. The same thing happened with Koi 55. This star began to increase in size and heat up in temperature, gradually turning into a blue-white giant. It was ready to devour its nearest planets. But Koi 55b didn't care about it. When the star reached it, this planet just settled inside. And moreover, after some time, it left its star, simply returning to the new orbit. How was that even possible? Life inside its star turned Koi 55b into a red-hot round stone. It's one of the hottest planets we've discovered so far. The temperature on it reaches 12,000 degrees Fahrenheit. It's hotter than the Sun, which is, let me remind you, an actual star. And for some reason, it's still alive and lives as if nothing happened. Unfortunately, sooner or later, the planet will disappear anyway. It's slowly evaporating itself due to the incandescent atmosphere. But still, it somehow managed to survive the journey through the star, which isn't typical for regular planets, to put it mildly. I envy this willpower. However, not all planets are so lucky. Some are gradually being destroyed by their stars, and there is even an entire system among them. This last planet is a sad loner. It's located 870 light-years away from us. The journey by ship to it would take about 25 million years. This planet is about 1.5 times more massive than Jupiter. This is a very sad, dark planet. A doomed gas giant, which is very similar to hot Jupiter, orbits its star all alone. At the same time, it's located so close to its star that its orbital period takes just 1 day. Of course, because of this proximity, the star gradually absorbs WASP-12b. The scorching heat of the star is slowly destroying and devouring the planet's atmosphere. The planet has only around 10 million years left. But what's more interesting, because of this stretching, WASP-12b acquired the shape of an egg. It doesn't even resemble an actual planet anymore. It's also very hot. The surface temperature of the gas giant reaches 4,000 degrees Fahrenheit. Also, a spectrograph of cosmic origin, or COS for short, found that the planet exchanges matter with its star. They're located so close that they give each other part of their chemical elements. This is a common phenomenon in closely spaced binary star systems, but this is the first time scientists have seen this in a star-planet relationship. What a unique system! To be honest, if I was guaranteed complete security, I'd be excited to visit at least some of them. What about you? Please let me know in the comments.
Okay, quick space riddle. Why is the search for life in the universe like a tree? Because you're always looking for a place to plant it. You know, plant it, planet. Okay, settle down. Anyway, water is the basis of life in any part of the universe, so potentially inhabited planets must have liquid water on them to support life. An incredible number of circumstances must come together for this. The planet must be in the habitable zone of the star. Then the temperature and atmospheric pressure on the planet's surface will be suitable for simple life forms to begin to evolve. A little closer to the star and the water will evaporate, leaving no chance for oceans and seas to form. This is what happened on Venus. It has a size and mass similar to the Earth, but it's too close to the Sun and no life can exist on its surface. Too far from the star, and the planet becomes too cold. Water can only exist in the form of ice on the surface, and there just might be liquid water deep below. Neptune is one example of this. In addition, the planet must be solid and have an atmosphere that protects it from solar radiation and allows living organisms to breathe. In our galaxy alone, there are countless stars. Really, you can't count on them. Near each one of them may be a planet. They're called exoplanets, and some of them may be in the habitable zone and have everything for life to form on them. From a list of 4,500 known exoplanets, scientists have identified 24 that can be superhabitable. This is the type of planet that is suitable for the existence and evolution of life, even more than the Earth. Such planets must be twice as massive as the Earth and 1.3 times larger. A bigger size means stronger gravity and a denser and warmer atmosphere. This will ensure a greater diversity of all living organisms on the planet. In addition, we should pay attention to the host star around which the superhabitable planets will orbit, and there should be a McDonald's nearby. Ideally, it should be smaller than the Sun and have a lifespan of at least 15 to 30 billion years. For comparison, the lifespan of the Sun is under 10 billion years, and it took about 4 billion for complex life forms to appear here. Stars such as the Sun can simply run out of fuel before life can develop on its exoplanet. Scientists suggest focusing on dwarf stars. They're smaller and less luminous than the Sun. but their lifespan can be between 20 and 70 billion years. This will give living organisms enough time to develop and evolve. Climatic conditions on super-habitable planets will also be different. The average temperature should be 8 degrees Fahrenheit higher than on Earth, and there should be more water in the form of clouds, liquid, and humidity. These conditions are the most favorable for biodiversity, so the whole planet would be looking like tropical forests on Earth. All 24 candidates for the title of Better Than Earth, are more than 100 light-years away from us. And with the advent of the new generation of telescopes, we'll probably be able to find out exactly if there is life there and if the conditions there are suitable for humans. Now, let's take a look at the potentially inhabited exoplanets. T-Garden b. It's an exoplanet that orbits a red dwarf star about 12 light-years away from the solar system. Typically, red dwarfs can emit flares that blow away the atmosphere of the planets in its orbit. But this host star is calm and relatively passive. T-Garden b has almost the same mass as the Earth. It makes a complete circle around its star in about 5 days. Yep, you got it right. A year on T-Garden b is less than a week on Earth. Hold on to your hats. The furthest potential inhabited planet is Kepler 1638b. It's in the constellation Cygnus, about 3,000 light-years away from us. It belongs to the Super-Earth class. It's twice as wide and 4 times as heavy as our home planet. The gravity on it will feel much stronger. Even a normal jump will be much harder for you than on Earth. Although, if this planet is really inhabited, local life is used to such conditions. LHS 1140b. This planet is very rocky and solid. Although its size is only 40% larger than the Earth, it's 7 times as massive. It has a strong gravity of 3.25 Gs. For comparison, when you take off on an airplane, you experience an overload of about 1.5 Gs. So on this planet, you'd barely be able to stand on your feet. Because of its large mass, this planet has a thicker atmosphere, and because of the greenhouse effect, its temperature can be above 19 degrees Fahrenheit, and it rotates around its star quite quickly. It makes a full circle in just 24 days. And now, let's look at the constellation Aquarius. Here's an ultra-cold dwarf, TRAPPIST-1. A small planet orbits in its habitable zone. It's 3 times lighter than the Earth. Its temperature is similar to ours, but the gravity is half as weak. But we would still feel comfortable there. Remember the people that went to the moon? There, the gravity is only 16% of the Earth's. That's what makes the astronauts move so funny. Kepler 452b is in a system that resembles the older sister of ours. The host star is only 11% older than our Sun and is almost 2 billion years older. The exoplanet itself is 6.5 billion years old, compared to 4.5 billion of Earth's. But these sisters are very far from each other. If you travel at the speed of the New Horizons spacecraft, it will take about 26 million years to get there, so bring a big lunch. This is the closest exoplanet to us, Proxima Centauri b. It orbits the red dwarf Proxima Centauri, which is the closest star to the Sun. This planet is just 4.2 light-years away from us. Its size and mass are very similar to those of the Earth. It probably has an icy structure, like Neptune. Although Proxima Centauri is the closest star after the Sun, we can't see it with the naked eye because it's too dim. So, all these planets, including the 24 that scientists have recently found, are in the habitable zone of their host stars. And, in theory, we can colonize them and make them suitable for human life in the future. But here we'll have to solve one big problem. Even the nearest exoplanet is too far away for us today. Our modern rockets can fly at 5 times the speed of sound, and even at such speeds, it will take us more than 100,000 years to get to Proxima Centauri on one of them. Well, we need to come up with something a bit faster to travel to a new home on one of these exoplanets. And perhaps scientists already have the answer. Warp drive. Ooh. This is a piece of technology that will allow us to manipulate space and time. It creates a kind of a bubble in which the normal laws of motion don't work. So the spacecraft will be able to significantly exceed the speed of light. And this isn't science fiction. Humanity already has such technology, although just in theory yet. It's Alcubierre warp drive. And no, I didn't make that up. Since no object that has mass can travel at the speed of light, we need to do one trick. The spacecraft has to move by compressing the space in front of it and expanding it behind it. Thus, not only the ship is moving, but also the space-time inside this warp drive bubble. And the maximum speed can be 10 times that of light. But to warp the space-time, the ship must be incredibly large. And to power it, we'll need the amount of energy close to what the whole planet of Jupiter generates. Still, recent calculations of NASA's Jet Propulsion Lab show that the ring around the ship, which should create the so-called warp field, shouldn't be perfectly round, as it was thought before. It can be more donut-shaped. Ah, donuts. This will greatly simplify the design and construction and will make it possible to test this technology on a spacecraft the size of a Voyager 1 probe. Even though it still seems impossible, scientists are already saying that there is hope. And while we don't know what technology will be used, in 2069, NASA plans to launch its first interstellar mission to explore potentially habitable planets outside of our solar system. Various rumors say that the speed of light can be achieved with laser technology. If the probe is very small, it can be launched to the Alpha Centauri star at almost the speed of light. There are also two other alternatives to power spaceships. These are nuclear energy and energy from matter and antimatter collisions. Ooh! These technologies are still a mystery to humanity, though. Well, for the time being, stay tuned. Venus most likely used to be covered with oceans, from 30 to 1,000 feet deep. Also, some water was locked in the soil of the planet. On top of that, Venus had stable temperatures of 68 to 122 degrees Fahrenheit, which, you have to admit, was quite pleasant and not that different from the temperatures on Earth nowadays. So, what I'm getting at is that for 3 billion years, right until something irrevocable happened 700 million years ago, Venus could have been habitable. But now it's not. The Moon is the second brightest object in our sky. At the same time, among other astronomical bodies, it's one of the dimmest and least reflective. Our natural satellite only seems bright because it's so close to Earth. For comparison, our planet looks much brighter when you look at it from space. It's because clouds, ice, and snow reflect way more light than most types of rock. Triton, Neptune's moon, has all its surface covered with several layers of ice. If this satellite replaced our current moon, the night sky would get 7 times brighter. Neutron stars are some of the smallest, yet most massive objects in space. They're usually about 12 miles in diameter, but are several times heavier than the Sun. Oh, and they also spin about 600 times per second, far faster than your average figure skater. Saturn is the least dense planet in the solar system. It has 1/8 the average Earth's density. And still, because of its large volume, the planet is 95 times more massive than Earth. A transient lunar phenomenon is one of the most enigmatic things happening on the Moon. It's a short-lived light, color, or some other change on the satellite surface. Most commonly, it's random flashes of light. Astronomers have been observing this phenomenon since the 1950s. They've noticed that the flashes occur randomly. Sometimes they can happen several times a week. After that, they disappear for several months. Some of them don't last longer than a couple of minutes, but there have been those that continued for hours. The year was 1969, one day before Apollo 11 landed on the Moon. One of the mission participants noticed that one part of the lunar surface was more illuminated than the surrounding landscape. It looked as if that area had a kind of fluorescence to it. Unfortunately, it's still unclear if this phenomenon was connected with the mysterious lunar flashes. Trash isn't just a problem in Earth's oceans, cities, and forests. There is a thing called space junk, which is any human-made object that's been left in space and now serves no purpose. There's also natural debris from meteoroids and other cosmic objects. There are currently over 500,000 pieces of space debris orbiting the Earth at speeds high enough to cause significant damage if they were to collide with a spacecraft or satellite. NASA does its best to track every single object to ensure that missions outside Earth can reach their destination safely. Our Sun is insanely massive. Want some proof? 99.86% of all the mass in the solar system is the mass of the Sun. In particular, the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. The Sun's temperature is hotter than the surface of a star. The surface temperature reaches 10,000 degrees Fahrenheit, but the upper atmosphere heats up to millions of degrees. If someone could dig a tunnel straight into the center of the planet and out the opposite side, and you were adventurous enough to jump into it, it would take you 42 minutes to fall to the other side. You'd speed up as you fell, reaching maximum speed by the time you reached Earth's core. After the halfway point, you would then fall upwards, getting slower and slower. By the time you reached the opposite surface, your speed would be back to zero. Unless you managed to climb out of the hole, you'd immediately start falling again, back down or up to the other side of the planet. This trip would go on forever, all thanks to the weird effects of gravity. Hey, might be a fun way to spend an afternoon. There might be more metals, for example, titanium or iron, in lunar craters than astronomers used to think. The main problem with this finding? It contradicts the main theory about how the Moon was formed. That theory says that Earth's natural satellite was spun off from our planet after a collision with a massive space object. But then, why does Earth's metal-poor crust have much less iron oxide than the Moon's? It might mean the Moon was formed from the material lying much deeper inside our planet. Or these metals could have appeared when the molten lunar surface was slowly cooling down. Or maybe, as they've been saying for centuries, it's made of green cheese. Earth could have been purple before it turned blue and green. One scientist has a theory that a substance existed in ancient microbes before chlorophyll. That thing that makes plants green evolved on Earth. This substance reflected sunlight in red and violet colors, which combined to make purple. If true, the young Earth may have been teeming with strange purple-colored critters before all the green stuff appeared. The highest mountain in the solar system is Olympus Mons on Mars. It's 3 times as high as Mount Everest, the Earth's highest mountain above sea level. If you were standing on top of Olympus Mons, you wouldn't understand you were standing on a mountain. Its slopes would be hidden by the planet's curvature. Astronomers have found a massive reservoir of water in space, the largest ever detected. Too bad it's also the farthest, 12 billion light-years away from us. The water vapor cloud holds 140 trillion times as much water as all the Earth's oceans combined. What are we supposed to do with that information? Venus spins at its own unhurried pace. A full rotation takes 243 Earth days, and it takes the planet a bit less than 225 Earth days to go all the way around the Sun. It means a day on Venus is longer than a year. There's very little seismic activity going on inside the Moon. Yet many moonquakes, caused by our planet's gravitational pull, sometimes happen several miles below the surface. After that, tiny cracks and fissures appear in the satellite surface, and gases escape through them. Hey, they sometimes escape from me, too. Now, Mars is the last of the inner planets, which are also called terrestrial since they're made up of rocks and metals. The red planet has a core made mostly of iron, nickel, and sulfur. It's between 900 and 1,200 miles across. The core doesn't move. That's why Mars lacks a planet-wide magnetic field. The weak magnetic field it has is just 1/100th% of the Earth's. When the planets in the solar system were just starting to form, Earth didn't have a moon for the longest time. It took 100 million years for our natural satellite to appear. There are several theories as to how the moon came into existence, but the prevailing one is the fission theory. Somebody went fishing and caught the moon? Actually, no. The fission theory proposes that the moon was formed when an object collided with Earth, sending particles flying about. Gravity pulled the particles together, and the moon was created. It eventually settled down on the Earth's ecliptic plane, which is the path that the moon orbits. So, looks like the green cheese is off the table now. The largest single living thing on Earth turns out to be a mushroom in Oregon. This enormous honey mushroom lives in Malheur National Forest and covers an area of 3.7 square miles. It could be as much as 8,500 years old. You could be forgiven for missing it, though, since most of it's hidden underground. When the roots of individual honey mushrooms meet, they can fuse together to become a single fungus, which explains how this one got so big. If you could gather all that mushrooming stuff into one big ball, it could weigh as much as 35,000 tons. That's about as heavy as 200 gray whales. Hey, that's a whale of a mushroom. Hehe. The largest asteroid in the solar system is called Vesta, and it's so big that it's sometimes even called a dwarf planet. A trip to the nearest star, apart from the Sun, would take you 5 million years on a commercial airplane. That's what I call a long-haul flight. Space isn't supposed to be black. There are stars everywhere. Shouldn't they light up everything around? Well, you don't see stars wherever you look because some of them haven't existed long enough for their light to reach Earth. A day on Uranus lasts 17 hours, 14 minutes, and 24 seconds. But get this, the planet has a tilt of around 98 degrees, and that makes a season on the gas giant last 21 Earth years. Now, some scientists believe that our planet used to have an additional satellite. According to their research, a small celestial body about 750 miles wide orbited Earth like a second moon. It most likely crashed into our main satellite later on. Such a collision could explain why the two sides of the moon look so different from each other, one being heavily cratered and rough. Or it could be the green cheese. The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler, NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. KOI 5715.01. Let's be coy, shall we? This wonderful planet is in the constellation Cygnus. And why is it so wonderful? Well, our sun is a yellow dwarf. And sorry, sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet KOI 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the Sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Now, our Sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Now, ideally, we would need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely there will be at least some organisms there. KOI 5715.01 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees Fahrenheit, which is slightly less than ours, 57. But it mostly feels warmer there because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light-years from Earth, which is about 18 quadrillion miles. Yep, better bring a really big lunch with you. KOI 3010.01. This planet is found next to the star KOI 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours. But that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on Earth. The more heat there is on the planet, the more comfortable it is to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.5 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The semblance is so striking that scientists believe we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? Now, what do you think they could look like? Very Earth-like planet, but with stronger gravity. Well, if someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near a red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our Sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. Now you'll probably say, but wouldn't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun, but its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today, it's just a red desert, and there's no life there. At least not as far as we know, but you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. That's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62e and 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62e is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, which is about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we talked about. Scientists believe that both 62e and 62f are sort of water worlds. warm places mostly, or even completely covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some, think Hawaii, and a nightmare for others, think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition, density? One day, maybe we'll be able to answer these questions. And so, that's it for the super Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these are planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are, a few of them have at least some form of life. But they're very, very far away, so we have no way to check it out right now. Perhaps, down the road, we'll find some cool creatures on many of them. TRES-2b is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES-2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri E is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side, and between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. HD 189377b, I'm not going to say that again, is the only exoplanet in the orbit of its star, and at first glance it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular, it's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler-70 is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protégé. WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven. And yet, it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very, very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. Still, if it has a rocky core, it might generate some heat. So there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1800 degrees, perpetually blown over with winds reaching 600 miles per hour. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Karat Exo 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Karat 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Karat 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core. We're used to thinking that asteroids are the only free-floating rocks in space, but things like OTS-44 make you think twice and shiver. Imagine a planet about 11 times more massive than Jupiter roaming in space without being bound to the orbit of any star. Given its gargantuan size and mass, if OTS-44 collides with any other planet, it would utterly destroy it and go on floating as if nothing happened. Scarier still, scientists are sure there are millions of such rogue planets out there, just waiting to be discovered. There's no hard proof of their existence yet, but theoretically, carbon planets have formed somewhere closer to the center of our galaxy. Any oxygen getting in their atmosphere will get into a reaction with carbon and transform into CO2, forming black toxic clouds. On the ground, there would be oceans made of tar, spewing up geysers of methane and crude oil. There would be rains, too, but they'd be far from refreshing. Torrents of pure gasoline and hot liquid asphalt would blast the ground and probably burst into flames on impact. Hard to imagine anything that would survive such conditions. Okay, here you are, in the middle of the ocean. It's endless, but you can't see it, because there's a thick fog all around you. Dense clouds hide the huge but dim sun. Is it day or night? You don't know. There's only a gray haze around you. You're alone. Even if you try to swim down, after several hours, you still won't be able to see the bottom of the ocean. And that's a typical water planet for you. I know, sounded kind of dark, but it's not that bad. These water worlds are more interesting than they may seem, so let's take a look at them. The ocean planet is a planet that consists, as you might have guessed, mainly of water, ice, and maybe some rocks. Think of the Earth's oceans. Its horrifying depths, the Mariana Trench, and all that. And now, can you guess how much space all the water on Earth takes up? 0.025%, exactly. Now, just try to imagine a world of 40 to 60% water. If you dive in there, the depth can exceed 60 miles. Compared to that, the 6-mile depth of our Mariana Trench sounds like nothing. And yeah, the pressure there will be enormous. It can reach up to 20,000 Earth atmospheres. Very crushing. Now, it may sound scary, but it still would be great to find out more about these planets. Fortunately, according to scientists' calculations, there may be a lot of such planets in our galaxy alone. Well, you don't have to go far. You can find these water guys even in our solar system. Not planets, of course, but moons. Jupiter has Ganymede and Callisto, and Saturn has Titan and Enceladus. The ocean can reach up to 30% of the mass of these moons, although it isn't clear whether these oceans are covered with a thick crust of ice. But we've discovered quite a few full-fledged ocean planets. This is because the conditions in which these planets may exist are very specific. For example, this planet should be somewhere 6 to 8 times larger than the Earth. If it's smaller, it'll have a rocky surface. But if it's bigger, it'll turn into a gas giant. At the same time, it must be in the habitable zone of its star. A little further, and the planet immediately turns into an icy giant or a cold super-Earth. So yeah, these guys are very picky. We first started exploring these planets back in the 1970s. However, since then, we found only a couple of them, but they're still very interesting. The first planet is Gliese 1214b. It was the very first ocean planet that we discovered. Initially, the scientists noticed only a small dim dot. This dot turned out to be the red dwarf star Gliese 1214. An unremarkable, completely ordinary star that's 5 times smaller than our Sun and 300 times dimmer. Scientists wouldn't worry about it at all, but back in 2009, they noticed that this star had one single planet, and this planet turned out to be quite strange. This super-Earth was 2.5 times bigger than our Earth and 6.5 times heavier, but at the same time, it had a very, very small density and about the same gravity as our planet. In other words, there were almost no rocks and metals on it. But it wasn't a gas giant either. So there was only one option left. It was covered in water and ice. And that's how we discovered the first ocean planet. Well, actually, we can only assume that it consists of water. That's what the mathematical calculations say. In reality, this planet is quite confusing. It's difficult to explore, and so far, scientists haven't been able to find anything there. No hydrogen, no helium, no water, nada. That's because the outer layer of the atmosphere of this planet is very dense, and it perfectly hides its composition. But even so, it's probably a water world. Gliese 1214b is very close to its star. It's only 0.014 astronomical units away, which is less than the distance between the Moon and us. The year there lasts about 36 hours, and the temperatures, to put it mildly, are just wild. Scientists suggest that the average temperature there can reach 250 to 535 degrees Fahrenheit. Woo, that's hot. Remember the creepy description from the beginning? Well, actually, spending time on Gliese 1214b would be a little different. more like swimming in a steam boiler. Because of such gigantic temperatures, the ocean on the surface will be constantly in a state close to boiling without actually reaching it. So, imagine that you're descending to the surface of this planet, flying through clouds of steam, and then you suddenly find yourself in the water. What? But when did it happen? Well, that's because the boundary between steam and water on Gliese 1214b will be very blurred. Of course, you won't be able to swim to the bottom of this ocean, but most likely, this bottom is covered with a very thick layer of so-called hot ice. It's like regular ice, but it doesn't really care about the laws of physics, so it just doesn't melt even at gigantic temperatures. And the thickness of this ice can reach as much as 3,000 miles. So that's it for the creepy Gliese 1214b, and not an Airbnb in sight. Now, although we can't 100% guarantee that it's a water world, we still have another candidate for this position. A newly discovered planet called TOI 1452b. This planet, located in the Dragon constellation, is almost 100 light-years away from us. It was discovered using the TESS telescope by a group of researchers from the University of Montreal. This planet also belongs to the class of super-Earths. It's 7 times larger than our planet, but 48 times heavier. Again, all this is at a very low density. Because of this, scientists have suggested that almost the entire planet consists of a giant ocean. Here, we were a little luckier. This world won't be just a giant puddle and some thick ice. On this planet, there's probably a rocky surface deep under the water, just like in a typical ocean. Don't get too excited though, this ocean will certainly be very different from what we're used to. TOI 1452b also orbits a small red dwarf, and not even one, but 2 at once. At the same time, if the previous planet was close to its sun, then this one, on the contrary, is very, very far away. It's 2.5 times farther from its stars than Pluto is from the sun, and it moves at great speed. A year there lasts only 11 days. But we still don't know many things about this planet. We'll probably get some new information when scientists observe it from the James Webb Telescope. Well, that's it. Wait, did you expect something else? Alright, I know the question that bothers you the most. Can there be life? Well, this is a difficult question. We all know that water means life, and besides, these planets are in the habitable zones of their stars. So, potentially, yes, there might be life. Not some full-fledged civilizations, of course, but bacteria, fish, and some creepy giant monsters. I mean, why not? However, this is very unlikely. Water alone isn't enough to create life, even though it's very important. There should also be some microelements and some minerals. And unfortunately, for most water planets, the composition will only consist of water and very thick ice. There won't be any minerals there. But don't give up. There's still some probability. First of all, there are meteorites and comets. They can bring the necessary minerals to the planet. The more often they crash into it, the higher the probability that they'll bring something like this into the ocean and thus create life. Secondly, TOI 1452b actually has these minerals. Yes, we don't know how deep the rocky bottom is located there. But if it exists, then surely something could have originated there. Let's hope that new research with powerful telescopes will allow us to find out the truth. And who knows? Maybe one day we'll be able to visit such a planet ourselves.
When you look at photos taken from spaceships or the International Space Station that show sunlit objects like Earth or the Moon, something seems wrong. Space looks too empty. No magical scenery of a nighttime sky full of stars. It would be incredibly boring to go stargazing in space, since the sky is always dark. During the daytime, the sky on our home planet is blue because of the diffusion of light. It happens when sunlight goes through the atmosphere. But if you were on the moon or somewhere else in space, there would be no atmosphere to spread this light around. That's why the sky there would always appear black. But it doesn't mean less bright out there. If you were looking out the window of the space station, you'd see just as much direct sunlight as you would gazing out of your apartment window during a cloudless day, maybe even more. When taking a picture on a sunny day, you'll probably use a short exposure, together with the narrow aperture setting on your camera. This way, just a short burst of light will get in. That's similar to how our pupils contract in sunlight so that they don't have to deal with too much light. And since it's just as bright up there in space, the process is the same when you take pictures of sunlit objects there. Using short exposure, you can get good, bright pictures of Earth or the surface of the moon. But it also means there will be no stars in the picture. Even up there, stars are relatively dim. They don't emit enough light to show up in photos taken with such settings. Our home planet has a blue sky that slowly transforms into a beautiful orange-red palette at dusk and dawn. But if you ever get a chance to watch a sunset on Mars, you should expect the opposite, an orange-brown daytime sky that gets a bluish tint at sunset. First of all, Mars is farther away from the Sun than our planet. So, when you're looking at the Sun from the Martian surface, of course, it looks fainter and smaller. And not just that, the Sun observed from Mars is just a bluish-white dot surrounded by a blue halo. The thin atmosphere of the red planet contains large dust particles. They create an effect called Mie scattering. It occurs when the diameter of particles in the atmosphere is almost the same as the wavelength of the scattered light. This effect filters out the red light from the Sun's rays, so only the blue light would reach your eyes on Mars. How come Earth doesn't have rings? All gas giants in our solar system, Jupiter, Saturn, Uranus, and Neptune, have such rings, whereas the rocky planets Mercury, Venus, Earth, and Mars don't. There are two theories about how rings can appear around a planet. They might be just some material left from the times when the planet was forming, or they may be the remains of a moon that got destroyed by a collision with some space body, or torn apart by the strong gravitational pull of its parent planet. The gas giants formed in the outer regions of our solar system, while all the rocky planets are in the inner part. So maybe the inner planets were more protected from potential collisions that could have formed their rings. There are also more moons in the outer regions of our solar system, which could be another reason why the planets there have rings. Also, bigger planets have stronger gravity. It means that they can keep their rings stable after they form. Some experts believe Earth used to have a ring system a long time ago. A Mars-sized object might have collided with our home planet, which probably created a dense ring of debris around it. Some scientists think that this debris formed not a ring, but what we know today as the Moon. There's probably a giant planet lurking at the edge of the solar system, far beyond Neptune. Scientists call this mysterious hypothetical world Planet 9. If it does exist, it's probably similar to Uranus or Neptune and 10 times more massive than our home planet. It's likely to circle around the Sun, but in the outer reaches of the solar system, about 20 times farther than Neptune. Another interesting theory says that Planet 9 could actually be a black hole the size of a grapefruit that warps space in a similar way a large planet would. Even though we once thought it was a rare substance in space, water exists all over our solar system. For example, you can often find it in asteroids and comets. It's also in craters on the Moon and Mercury. We still don't know if there's enough water to support potential human colonies if we decide to move there, but some amount of water is definitely present there. Mars has water at its poles too. It's mostly hidden in the layers of ice and probably under the planet's dusty surface. Europa, Jupiter's moon, has some water too. This is the most likely candidate we know about to host life outside Earth. There's probably a whole ocean of liquid water under its frozen surface. It might actually contain twice as much water as all of Earth's oceans combined. Neptune is unexpectedly warm, even though it's 30 times as far from the Sun as our planet and receives less sunlight and heat. But it still radiates way more heat than it gets. It also has way more activity in its atmosphere than you'd suspect, especially if you compare it to its neighbor, Uranus. Both of these planets emit the same amount of heat, even though Uranus is much closer to the Sun. No one knows why. Neptune has extremely strong winds that can reach a speed of up to 1,500 miles per hour. Can they produce this heat? Or maybe it's because of the planet's core, or its gravitational force? There's a monster black hole hurtling through space at a speed of 5 million miles per hour. Scientists located it with the Hubble Space Telescope. They believe it weighs as much as 1 billion suns. It was supposed to stay put in the center of its home galaxy, but some gravitational forces are pushing it around. At one point, this black hole is going to break free from its galaxy and continue roaming the universe. Luckily, it's still 8 billion years away from us. Solar storms are so powerful that they could leave us in complete darkness. Back in July 2012, the strongest solar storm in over 150 years narrowly missed Earth. Coronal mass ejections, or CMEs, are large bubbles of ionized gas. They tore through our orbit back then. If they had caught our planet in the crosshairs, we would have literally been in the firing line. We'd have faced solar matter hurtling towards Earth, damaging computers and causing power outages that would have lasted for months. A surprise solar storm hit us on June 25, 2022. One photographer even managed to capture stunning bright auroras that flashed across the dawn sky in Calgary, Canada, and lasted for 5 minutes. They were caused by the storm. Vampire stars are a real thing. They're part of a binary star, and they can literally drain the life out of the other star in the system. They do it to keep burning for a longer time. It works like this. A smaller star with a lower mass steals its sibling's hydrogen fuel to increase its own mass. This vampire star then becomes hotter. Plus, its color changes to striking blue. This way, it looks much younger. How sneaky. The color of the universe is dubbed cosmic latte. The light coming from our galaxies and stars within them, as well as clouds of gas and dust in the observable universe, have a specific color. It's an ivory tint, pretty close to white. The universe is beige because there are a bit more areas that produce green, yellow, and red light than those that emit blue.
The weird thing about Fomalhaut b isn't its name, but the fact that it doesn't exist. It was first photographed back in 2008 and was a sensation. Scientists believe it to be a massive exoplanet, but it turned out to have low mass, and it's falling to pieces of dust at the moment. It acts like a massive dust cloud. Gliese 1214b is quite extraordinary with its steamy environment. Wait, but steam is the result of water evaporation, isn't it? In fact, this hot planet is full of water-like substances. It's definitely hotter than our planet, with its 250 to 540 degrees Fahrenheit. It can also be an ocean planet. Still, very little is known about it since it was first discovered only back in 2009. If you ever wondered what it's like to walk on ice and hot coals at the same time, meet Gliese 436b. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. But Gliese seems a nice place with quite mild climate compared to an oven-like Corot 7b. Its stated day temperature is over 4,000 degrees Fahrenheit. Combined with the rocky surface, it presents a kind of underworld landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Corot 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core. Corot Exo 3b is neither as hot as the previous one, nor as cold as many other planets. It's a gas giant similar in size to Jupiter, yet 20 times denser. It makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. TRES 2b is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here, it's pitch dark and scorching hot. TRES 2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. It may mistakenly seem that Saturn does have an Earthen-friendly environment, Some layers of this giant gas sphere actually have quite nice temperature conditions. If you dive into Saturn, you'll get to a layer with liquid molecules with 32 degrees Fahrenheit, which seems like Earth. Anyway, it's only one minor layer, and the rest of the planet is freezing cold. So you'll never be able to land on Saturn and be the same human being like you are on Earth. But you can become a sort of snowball there, or an ice crystal. As for Jupiter, you might have already guessed that there's no solid land. This planet is made of hydrogen and helium, so it's another gas sphere you can't walk on. It's a bit different from Saturn, though. You wouldn't dive in Jupiter, you'd rather float on it. This planet is like a giant cloud, and if you ever landed on it, it would be like walking through a super thick fog. The temperatures fluctuate a lot here. It's freezing on the surface. Unlike Saturn, the deeper you dive, the more scorching this gas sphere gets. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot where anything that could burn will. It's also responsible for a very short orbit of the planet around its star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. WASP 76b is another weirdly dangerous planet where it rains. No, not wasps. It's so hot out there, over 4,300 degrees Fahrenheit, that it vaporizes iron. So, it rains iron. It's another gas giant, just like Jupiter. Its extreme proximity to the sun divides the planet in two. One half has a never-ending day, while the other has eternal night. Meet WASP 12b, one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planet consisting mostly of gas, result in the star slowly devouring its protege. WASP 12b has already taken the form of an egg, stretched towards its merciless sun and unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. No list of the weirdest planets could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury, despite being somewhat farther from the Sun. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water, but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through those clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. One more freezing cold planet is the one I dare not pronounce. Although the host star is not too far away, it's a small and rather cool red dwarf whose light and heat barely even reach the planet. The temperatures out there fall as low as -370 degrees Fahrenheit, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice. Still, if it has a rocky core, it might generate some heat, so there is a chance that deep below the frozen surface, we could build a nice thermal spa hotel for space travelers. The next planet that sounds like a tongue twister is the only exoplanet in the orbit of its star, and at first glance, it looks quite pretty. Blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst thing is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. For comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, The glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Here's another name we'll just leave on the screen, thank you. This magnetic rogue planet, let's call it SIMP, has probably the best auroras in the universe, putting our northern lights to shame. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1800 degrees Fahrenheit, perpetually blown over with winds reaching 600 miles per hour. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when these cool down, they fall on the surface in the infernal rain of molten iron. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather, the first, because it's closest to the star, is different in a most horrible way. 55 Cancri E is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star with one side. And between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. The system, whose name I wouldn't even try to pronounce, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular one. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions, while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely.
Now, Mercury is the planet that's usually closest to Earth. Does that surprise you? Did me. Venus certainly gets closer to us than Mercury. It can be as close as 25 million miles. After all, Venus is the second planet from the Sun, and Earth is the third. Even Mars gets closer to Earth than Mercury. The red planet can come as close to our home as 35 million miles, as it will in the year 2287. I won't be around for that. The average distance from Earth to Mercury is 48 million miles, but Mercury is still usually the closest planet to Earth. That's because Venus is usually somewhere on the other side of the Sun for 112 days, and Mars is usually far away in its highly elliptical, almost 2-year-long orbit. That leaves Mercury zipping between the Earth and the Sun every 44 days, and thus usually closer to Earth than either Venus or Mars. Hey, good trivia question to pull on your friends, isn't it? 22 spacecraft have successfully flown to Venus, and over 30 spacecraft have flown to Mars, but only 2 have ever gone to Mercury. So, what's so hard about going there? Well, it has to do with the Sun. Mercury is not only the planet that is usually closest to Earth, it is also the planet that is always closest to the Sun. 28.6 million miles close, to be precise. Being that close to the Sun creates navigational challenges, to put it mildly. Any spacecraft going to Mercury gets accelerated by the tremendous gravitational pull of the Sun. The spacecraft will be moving too fast to go into orbit around Mercury. That's why the first spacecraft that went to Mercury, the USA's Mariner 10, merely flew by Mercury 3 times, but made no attempt to achieve orbit around Mercury. The only other ship to go to Mercury, the USA's Messenger spacecraft, took 6.5 years to get there. Now that's a trip. Messenger did achieve orbit for a period of 4 years before finally running out of fuel and crashing onto the surface of Mercury on April 20, 2015. Many other spacecraft have flown to Jupiter in about the same time or less than it took Messenger to go to Mercury. The hang-up is the deceleration of the spacecraft. Quite simply, it takes too much onboard fuel supply to fire the engines in the reverse direction and brake the speed of the ship against the Sun's great gravity. Slowing down sufficiently to get into orbit around Mercury is a no-go using rocket power. Some other way had to be found to slow Messenger down, a way that didn't use much or any fuel. Messenger was a hefty 2,400 pounds or so, loaded with 9 pieces of state-of-the-art scientific equipment. Now, 55% of the total weight, or about 1,300 pounds, was fuel. But this fuel would not be used to slow the spacecraft down. The fuel would be used for 5 engine burns associated with gravity assists and also for orbital adjustments once Messenger got to Mercury. Now, gravity assists uses the gravity of a planet and the planet's orbital velocity to either speed up or slow down a spacecraft. If the ship approaches a planet at a forward-moving angle, that is, an angle in the direction the planet is revolving around the Sun, then both the planet's gravity and the orbital velocity of the planet give the spacecraft a slingshot boost, greatly increasing the speed of the craft and sending it off in a different direction. This boost in speed can be added to by the spacecraft firing its rocket engines at just the right time. Both of America's Voyager probes used Jupiter's massive gravity to slingshot them to the outer gas giant planets and eventually out of the solar system. Gravity assist can also be used to slow down a spacecraft, as in the case of Messenger. By entering a planet's orbital path ahead of the planet's gravity pulls back on the spacecraft and slows it down. An engine burn is necessary at this time to escape the orbital path of the planet. Messenger performed 1 gravity assist flyby of Earth, 2 gravity assist flybys of Venus, and 3 gravity flybys of Mercury. Only then had Messenger been slowed enough to enter into orbit around Mercury. The probe traveled an astounding 5 billion miles to get to Mercury from Earth. That's farther than Pluto is away from Earth at its most distant. The name Messenger is an acronym, almost as clever as its intricate flight path to Mercury. Because Mercury is the fastest-moving planet, the ancient Greeks appointed Mercury as the messenger of Olympus. News traveled fast even back then. Messenger really stands for Mercury Surface, Space Environment, Geochemistry, and Ranging. What do you think? Did they have a contest to come up with that? Now, the good news is, there's another mission to Mercury underway right now. It is a combined ESA-JAXA space mission that is bringing 2 orbiting satellites to Mercury. The mission doesn't use an acronym for its spacecraft, it has a real name, Bepi Colombo. No, it's not a cartoon character. Dr. Giuseppe Colombo, after whom the spacecraft is named, was an Italian mathematician and professor of applied mechanics. He worked with NASA on the Mariner 10 mission to Mercury. Bepi is Giuseppe's childhood nickname, which everyone knew and loved him by. NASA had been content with 1 flyby of Mercury, the first ever, but Professor Bepi calculated that with a slight adjustment of the flight path to enable a gravity assist at Venus, Mariner 10 could fly by Mercury again and again on different orbits around the Sun. Thanks to Bepi, NASA got 3 flybys of Mercury for the price of 1. Bepi Colombo, the spacecraft, is scheduled to perform 9 gravity assist flybys, 1 at Earth, 2 at Venus, and 6 at Mercury itself. Each planetary deceleration slows Bepi Colombo relative to the speed Mercury is moving around the Sun. This will allow for orbital insertion. Otherwise, Bepi Colombo would head off into the Sun. Now, once in orbit around Mercury, Bepi Colombo's Mercury Transfer Module, or MTM for short, will release 2 satellites, 1 European, the MPO, Mercury Planetary Orbiter, and 1 Japanese, the MEO, Mercury Magnetospheric Orbiter. Both are expected to orbit Mercury for 1 year. Altogether, the MCS, Mercury Composite Spacecraft, consists of the MPO, the MEO, the MTM, and MOSIF, which protects the spacecraft from the Sun and houses the electronics for MEO. This alphabet soup of mission components highlights the other reason it is difficult to get to Mercury. After 6 gravity assist slowdowns, 6 engine burns, 18 orbits around the Sun, 6.5 years of travel time, and 9 billion miles of distance, you have to bring a tailored complex of equipment. It's like that mountain picnic you'd like to go on. You can't just drive there. You have to hike a long way up a tricky mountain trail and bring along insect repellent, sunscreen, and your hat. Oh, and lunch and beverages. It's not easy. Bippo Colombo has packed it all, including lunch. Nah, not really. The design is incredibly complex. Nothing can face the sun, not even the solar panels. The solar panels must be kept turned almost to a right angle to the sun, or the heat and particle flux will corrode the solar cells, and without electricity, you have nothing. Therefore, at right angles to the sun, the solar panels must be extra long, as if there were only a little bit of sunshine. Beppi's solar panels are 50 feet long. The sun shield must remain gyroscopically aligned towards the sun so that all instruments are always in the shade but still have a line of sight to what each is meant to monitor. And there are a lot of instruments, 5 in the JAXA orbiter and 11 in the ESA orbiter. It's one amazing picnic. Anyway, the science objectives are meant to add to what we have learned from the previous 2 missions to Mercury. The data collected by Bepi Colombo will enable scientists to study the planet's interior and composition, along with Mercury's geology and surface morphology, Mercury's magnetic fields formation and evolutionary history, the planet's solar wind interactions, and overall environment. As a metal-rich planet, Mercury may hold a vast wealth of minerals that MESSENGER failed to detect. Bepi Colombo launched in October 2018 and still has a long way to go before it goes into orbit around Mercury. However, Bepi has already flown past Mercury and returned new photographs. The European Space Agency is excited about its first hot mission. All of the ESA's previous missions have been cold missions to objects further out into space, such as Mars, the asteroid belt, Comet Rendezvous, and elsewhere far out in the solar system. Well, all I can say is, best wishes to Bepi Colombo. Let's hope all goes well on its 800 degrees Fahrenheit mission to Mercury. Let's hope that Mercury's long tail of exosphere gases, sodium, magnesium, and potassium, blown off the planet's surface by the solar wind, don't fog up the lenses or coat the solar panels. Have a nice time! Ciao, baby!
You take a giant straw and begin to inflate Saturn. It's getting bigger and bigger and bigger. That's enough. Now let's add some giant rings. That's it. This is Super Saturn, also called Saturn on steroids. It's a real object that scientists discovered in 2012, a planet named J1407b. And astronomers are still not sure what it really is. It could be a gas giant, like Jupiter or Saturn in our solar system. Then there would be no solid surface there. And if you wanted to set foot on that planet, you just fall through it, all the way to the core. But it could also be a brown dwarf. That's something between a large planet and a full-fledged star. Such objects have to be heavy enough to start thermonuclear reactions, like those going on inside stars. But the power of these reactions is too weak for brown dwarfs to glow and emit heat. To imagine the size and weight of J1407b, let's look at our Earth. If you put our planet on a scale, it'll show 6 and another 21 zeros tons. Our planet is also about 7,900 miles across. Now, that's Jupiter, the largest planet in our solar system. Its diameter is 11 times as great as that of Earth. It's also 318 times heavier. If Jupiter were a bucket, you could put 1,321 Earths in it. And this is the hero of the day, Super Saturn. It's almost 20 times as large as Jupiter. To balance the scales, you need to put 6,360 Earths on the other side. The planet's rings are so wide that if they were in the solar system, they would take up more than half the space between the Sun and Earth. And if Super Saturn switched places with the original Saturn, you'd see those rings with the unaided eye. They would be larger than a full moon. Presumably, these rings appeared in the same way as the ones around our Saturn. One theory says they're the remains of a moon that was once there. Its orbit was unstable, and over time, the moon got torn apart by the tidal forces of the huge planet it orbited. Small pieces of the former moon took their places in the giant's orbit. They collided with one another, like in a blender. After some time, everything that was left was basically particles of dust and ice moving around the colossal planet. Another theory suggests that the rings appeared after the moon collided with an asteroid or another moon. Then the gravitational blender did its job and turned the moon's debris into the rings. Some scientists think the rings formed at around the same time as the planet itself, so they're just the remains of the planetary nebula, which is a cloud of gas, space debris, and dust. Later, it probably shrunk and solidified to form a planet. We can only guess where Super Saturn got its rings from, but scientists say their mass is 80% of that of Earth. It may mean that the moon that used to orbit J1407b was about the same size as our planet. There's a little gap in the middle of these rings. Scientists think Super Saturn's moon might be there. If this is the case, it should be about the size of Mars. If scientists are right and Super Saturn is actually a brown dwarf, then this is an incredible discovery. Scientists will be able to watch it age. Supposedly, brown dwarfs lose their energy and shrink, fading in the process. And when a brown dwarf exhausts all its energy, it turns into a black dwarf. It's easy to confuse it with a black hole. People haven't discovered black dwarfs anywhere in the universe yet, because they take trillions and quadrillions of years to form. Our universe is too young, and none of the stars, even those that appeared when the universe was born, have had time to become black dwarfs. One of the oldest objects in the universe is the white dwarf, with a pretty long name, WD 0346 plus 246. It's about 11 to 12 billion years old and half as cold as our sun, and it's still cooling. It would need around 10 plus another 15 zeros years to turn into a black dwarf. For comparison, the universe is 1.4 and 10 zeros years old. Scientists believe that a black dwarf will exist for about 10 plus 25 zeros years, feeding on dark matter. After that, its protons, the smallest particles of matter, will begin to decay. And then, the black dwarf will simply evaporate. That will take another 10 plus 49 zeros years. But if the protons remain intact, a much more interesting scenario will await the black dwarf. In another 10 and 1500 zeros years, the black dwarf will become an iron star. It's essentially just a cannonball in space. The iron sphere will exist billions of times longer than our entire universe has existed, until it suddenly turns into a black hole. So, the process of the formation of a black dwarf is extremely long. It'd take a regular star an insane amount of time to age that much. But Super Saturn, if it is a brown dwarf, may be much closer to this state. Saturn on steroids is not the only strange planet in our universe. This is Gliese 436b. It's been detected using the transit method. A transit happens when a planet moves between its host star and an observer. It looks similar to a lunar eclipse. This planet is 4 times the size of Earth and 22 times as heavy. That's almost like Neptune. It's an exotic water world. The water there is solid, but it's not ice. It has a temperature of about 520 degrees Fahrenheit. The water in your pot turns into steam at 212 degrees Fahrenheit. But on Gliese 436b, the liquid remains solid because of the extreme pressure on the planet. Scientists have also discovered that the planet's atmosphere is evaporating into outer space. That's why there's a giant circular cloud around it. It's constantly moving in its orbit, giving the planet a long tail that looks like that of a comet. Cancri E holds incredible riches worth more than all the money on Earth. There are diamonds scattered all over the planet. Cancri E is about twice as wide and 8 times as heavy as Earth. This planet doesn't rotate. Only one of its sides always faces its host star. The surface temperature there is almost twice as high as the temperature of a burning fire. And since the host star is rich in carbon, the planet contains plenty of this element too. The intense pressure and temperatures help turn carbon into graphite and diamonds. Unfortunately, this planet is 40 light years away from our home, so it'd take about 730,000 years to get there on a regular rocket. Another planet rich in gems is HAT P7b. It's about 1,000 light years away from Earth. It's 60% as large and nearly twice as heavy as Jupiter. The planet is so close to its host star that it makes one revolution around it in just 2 Earth days. Because of such close proximity to the star, Hat P7b is almost as hot as a white dwarf. If you look at the night side of this planet, you'll see unusual clouds. Scientists believe that these clouds may be rich in corundum material. This is the very substance that forms rubies and sapphires, so it's likely to rain very expensive and beautiful gems there. WASP 12b is one of the darkest planets ever discovered. Only one of its sides faces its host star. The planet's surface is so dark that it eats up about 94% of all visible light, so it looks a lot like a black hole. The host star heats up the planet so much that the material there continuously evaporates. Then the star's strong gravity pulls this cloud toward itself, forming a disk. But TRES-2b is the champion. It's the darkest planet known to people. It absorbs 99% of the light coming from its star, which means it consumes more light than a piece of coal. 1% of the remaining light looks red as it gets reflected by this gas giant. From afar, this planet looks very evil. One of the oldest planets in the universe is PSR B1620-26b. It's about 12.7 billion years old. This means that it formed about 1 billion years after the Big Bang. The planet is so old that its two host stars have had time to evolve. One is a white dwarf. The other is a pulsar that makes almost 100 revolutions per second. Sunrises on this planet must be stunning. Right now, this star system is moving toward a dense cluster of stars. This is likely to lead to a stellar collision, so the fate of this planet is unknown. Kepler 438b is one of the most Earth-like planets. It's only 12% larger and is in the habitable zone of its host star, not too close and not too far away. It's a sweet spot where water doesn't evaporate because of the heat and doesn't turn into ice because of the cold. This planet might host life on its surface. In the future, it may also become a new home for humanity, but it would take people about 470 years to get to this planet, even if we traveled at the speed of light, which is impossible due to the laws of physics.
You're on a spaceship flying through outer space at a speed of 180,000 miles per second. This is almost the speed of light. Make yourself comfortable, because the voyage is going to be long. It will last a little more than 90 years. It's better to use a cryo capsule to not get bored. In short, you need to fly for almost a century at the speed of light to get to a mysterious exoplanet that scientists have recently discovered. They have found many planets in the last few years, but this one can help in the search for extraterrestrial life. The planet looks like a dark blue ball and has a complex technical name consisting of letters and numbers. It's about the size of Neptune and orbiting around a little star of class M, or in simple words, around a red dwarf. The planet is 8 times closer to its star than Earth is to the Sun. But this doesn't mean that fiery layers of magma cover the surface of this world. The temperature on this exoplanet is pretty low and similar to Earth's. That's because the red dwarf is not as hot as our Sun. But the most exciting thing is that the atmosphere of this space object consists of water vapor, or helium hydrogen. Scientists don't know for sure, so they actively observe it. But if there is water in its atmosphere, then life can exist. It's unlikely we will discover some big creatures, but even microscopic bacteria would be a big sensation. Another reason why scientists keep their eyes on this planet is its origin. If they find out what the planet's atmosphere is made of, they'll understand how such objects can form around red dwarfs. This will be another little brick of understanding of how the universe works. Even if they discover life on this strange planet, it will be impossible to transport it from there for us to study. Fortunately, there's another massive object near Earth where microbes can live, and it's located inside our solar system. In 2020, scientists detected a strange gaseous substance in Venus's atmosphere. These were chemical residues of phosphine. This is a significant finding because phosphine exists on Earth near some microbes. They've recently discovered phosphine in penguins' bodies. Many people started to put out theories that these animals came to us from Venus. But, of course, this is not true. You can also find this substance among swamps and mud. So it was a big surprise when they found residual phosphine parts on another planet. It's weird, since life on Venus's surface most likely cannot exist. The temperature and pressure on the planet are just too high. But high up in the sky of Venus, the conditions are not so terrible. Perhaps some microbes live there. But scientists also know that volcanoes often erupt there. A chemical trace of phosphine may appear as a result of these eruptions. If this is the real reason for the appearance of phosphine, they probably won't find any life. Now they're spending a lot of money on the study of this planet. But let's go back to deep space. Over the past 20 years, scientists have been finding exoplanets far and not too far from us. Some of them orbit around dwarfs and big stars, but some planets exist entirely alone. They don't belong to the orbit of any star. They are abandoned in cold outer space. Another exciting thing is that scientists haven't found a planetary system similar to our solar one. All distant exoplanets are located at different distances from their stars. Their sizes and masses are not like those that our planets have. We call them exoplanets since they're beyond our solar system. Some other fascinating space objects are super-Earths. If some planet weighs from 2 to 10 Earth masses, is 2 times bigger, and gets energy from a star, it's called a super-Earth. No more similarities with our home. Super-Earth can consist of gas, rocks, water, ice, fire, acid, glass, or diamonds. Scientists haven't yet found a super-Earth with ideal conditions for humans. Not because all planets are bad for life, but because our body has evolved and adapted to Earth only. We don't know much about super-Earths. They contain a massive amount of energy because of their enormous masses, and this energy is released. Therefore, frequent volcanic eruptions and earthquakes occur on many of these planets. Thunderstorms happen there almost every day. And by the way, one day there lasts several times longer than our 24-hour one. Let's imagine you're on the spaceship again, traveling to some super-Earth. So here it is, massive, orange, majestic. You put on a spacesuit, get into a space capsule, and you change your mind. The whole planet resembles a fiery, boiling ball. If it has any life, it must be some invulnerable creatures. You're not like that, so you fly away to look for another super-Earth. A couple light years away, that giant ball seems to be a friendly place. Wait, this world is located far from its star. The temperature there is so low that even molecules freeze. Antarctica is like a hot desert compared with this super-Earth. You continue your voyage and finally find a perfect spot. It's 3 times heavier and twice bigger in size than Earth. It consists of rocks, gases, and possibly water. You descend to the planet on the transport capsule, open the door, and take one step. Your legs are too heavy. Your whole body has gained weight. You feel as if you were carrying a huge box of bricks on your back. You can't even walk a few feet. And the reason for this is gravity. The greater the weight the super-Earth is, the greater its gravitational force becomes. You're pressed to the ground, and your muscles are too weak for this. Also, increased gravity provokes active fluctuations of tectonic plates. Earthquakes and landslides happen on this planet pretty often. The rocky surface here is constantly changing. To live on such a planet, you would need to develop new technology to build houses. You get back into the capsule and fly away, but not too far. The planet's gravity doesn't allow your ship to rise high into the sky. It's like ropes pulling you down. You use all the remaining fuel to overcome the gravity and go beyond the atmosphere. Another problem with such worlds is meteorites. Gravity attracts not only your ship, but also colossal space objects flying by. A giant asteroid can get off its route because of the attraction of the super-Earth. It can hit the planet in the form of a meteor shower, but the falling speed is also faster, so the destruction will be more massive. But the worst thing that can happen to the super-Earth is the stoppage of the planet's core, caused by high pressure. Hundreds of billions of tons of solid rock can squeeze the heart of this world, and the core should always be in motion to perform its primary function, keeping the magnetic field working. Solar storms and cosmic radiation can create severe problems for all life on the surface. On Earth, these storms disrupt the operation of electronics and affect human health. This happens even if small holes appear in the magnetic field. And what would happen if all the protection disappears? The energy of the closer star and the radiation from distant space would quickly destroy the super-Earth and make it impossible for life to develop. All these events can happen to a super-Earth with ideal conditions for living, and such a planet is a rarity. Most super-Earths have terrible surfaces and atmospheres. There's a planet where the air is so hot that it can evaporate metals. The fiery wind simply splits any solid substance into molecules. Such a super-Earth is more like a star, not an ordinary planet. Also, there's another super-Earth, wholly covered with water. You won't find a single piece of land there. The ocean floods any island in a second. And underwater, there are volcanoes. They erupt almost every hour, releasing billions of tons of magma. Because of the heavy weight, the planet is slightly tilted. When it rotates around its axis, the water flows from one side to another. This creates huge destructive tsunamis bigger than the size of Everest. And how about a super-Earth where it's raining diamonds or sulfuric acid? The surface of another distant world is blown by winds consisting of glass. There's a lot of fire and sand. When the hot air burns the sand particles, they turn into glass. Among all such planets, ours seems to be a paradise. But perhaps for some strange organisms living at the distant end of the galaxy, Earth may seem to be a terrible world.